Okay. Getting started later than I said I was going to because OBS is fucked. But oh well. We'll have to fix it yet again. Always fixing OBS. It's my whole life at this point. Okay, let's see. This is 1314. Maybe I can actually do this for real this time. If we go here. Oh yeah, I was gonna try this real quick. What was I doing? I already forgot. To here to see what the offset was supposed to be. 1312, 1310, around there. Okay, we'll do 13. Exciting stuff. We are gonna get into Rust in a minute. I just have to get over my skill issues here. All right. Let's go here, and then we can move this all the way over here, and then we just go there. It actually looks smaller than it usually does. It should be about there. Yeah, that's fine. And of course I did that. Okay. All right. So that's good. Let's fix chat now. This won't take too much longer. There's chat. And we make it wide enough. No, that's too wide. And there. That's better. And then we go down until we have just before send message. And that should be good. Okay. Chat should be done. That should be done. Okay, cool. So now that we got chat working, it should show up on solo term. We just need VLC to... So we're just going to copy the VLC transform and then paste it here. And that will just magically work. This is a little bit fucked, but it's not the biggest deal. Let's see. I don't want it to maintain aspect ratio. Maybe I should just... we'll just fix coding, and then we'll move on. Once coding's working, that's really what matters. Okay, so we'll paste the VLC transform here, and that actually might be fine. It might need to go down a tiny bit once we actually fill up our terminal. Yeah, that's the problem. Okay, there it is. Clicked into place. Okay, we should be ready. This is good enough. It's not beautiful, but it's good enough. Good enough for today and the many problems we've decided to face. Okay, cool. Thanks for bearing through. Jesus Christ, I can't even speak English. All right, cool. I think all I need is the room light on so I can see a little bit better, and we'll be good. We'll get into our binary search tree again. Okay, cool. So that was fun. It's basically what I have to do every time I restart my computer, which is very stupid of me. Oh yeah, I have to start the oven because we're baking some potatoes. All right, give me 1 second. I have to go just turn the oven on. Alright. Maybe the last distraction. We'll find out. We never really know. That is a little bit off. I see why my VLC is kind of screwed up, but gonna let it go. Gonna let it go. It's fine. Alright. Let's get into it. I guess we should tweet now that we're over all of that craziness. We can tweet that we are streaming. I have an hour to finish to work on my binary search tree in Rust. Come join us at twitch.tv/metame. That's me. And here we are. Cool. This was a pretty awesome. I was pretty happy with this one. This one's pretty good. Why is it showing me the tweet button when I click on it? It's hilarious. Dylan made it, but it's still funny. Okay. Good times. Let's just fill up chat with something. There we go. Good. We can see things. And I think I'm right. So let's open up our file. Okay. And where are we? We are here. It's actually working on the left side. But we also ended up... Oh, I remember. I was refactoring this. And I actually need to update the parents reference when I actually delete this, which gave me pause and made me think, maybe I can't actually do this, which would suck. So basically I have to decide what I want to return. Now I have an option. I could actually return, instead of returning the deleted value from delete, which I don't exactly need it to do, I could just have it return like the optional. Let me think how this would work. So if there's a swap, then we're just going to update the swap value. Otherwise, we're going to set the parent dot left to none. Let's just change this to parent right now so we don't get confused, even though this won't work the way that it's done. So maybe what I want actually, like the biggest piece of this logic is this swap node. So maybe instead of calling delete there, I actually just like take out this swap node stuff. So let me just think about this. Let swap node. If let sum left, and then we get the rightmost. If rightmost is sum, self dot replace left with left child. Yeah. Right, which we don't have a problem with. And if there's an actual value there, then yeah, okay, okay, I'm getting it, I'm getting it. If there's a value in the swap node, then we're gonna update our value to the swap node value. Yeah. Okay, so let's just start by factoring that part out, and then I think we'll be closer to understanding what's happening. Function. I mean, we could actually say swap node, and then let me think. Because that would do everything up to this. And then if there's no swap node, we return a none to say that, like, we didn't swap anything. Ooh, I don't hate that. I don't hate that. Let's see. So, otherwise we just return, we could return some value, or we could just return the actual node. I don't know. It doesn't exactly make sense to yeah, it doesn't exactly make sense to do that, but just give me a second. I have to think about what I'm doing. So we shouldn't even need a value. Let's just return an option self for now, and then see how this goes. And I'm pretty sure what I want is basically everything, including the 15, everything 15 lines down. I think that's what I want to take out of here. Okay. Else none. Oh yeah, but this actually just checks. So actually what I can do instead of this, we'll change that. And instead we can just return swap node. Now technically that's an option box node T, not an option self. But that's not a bad thing. And obviously it should not have that. Okay, okay. I don't hate this so far. Yeah, let's just put a box in here and we'll see if this return value actually makes any sense. It may not. Yeah, this isn't bad. This isn't the worst thing. To swap node value. Yeah, but we don't want to do that. That comment doesn't even make sense anymore. And then here under delete, which we don't even want this whole thing. So let's just delete all that. Oh yeah, I forgot. Darn it. I'm supposed to record. It's alright. I'll just record from here. I forgot that I was going to do that today. We'll see what happens. Okay. No. Not what I meant to do. That's what I meant to do. Okay. So we don't have an n.delete anymore. What we have is a swap node. Now what I meant to do. Okay. Here we go. So then if n equals value, we're going to swap it. And if there's none on, so this is a little bit funny syntax. If let none equals, usually we're used to destructuring with sum. I mean, we could just say if n.swapNode.is none. I guess that makes more sense since we don't need the destructuring. So we might as well do that. Then we're going to say self.left equals none. Yeah, so let's is none. Okay, then self.left equals none. Okay. Right, and then it's just saying we're not returning our option T, which is fine. We can actually just do some value there. Okay. That's much cleaner than where we were at. So let's just read through this and see if we like what we've done. We don't need all this. It's still true that it doesn't work for deleting root node, which is kind of why it's delete from. That makes sense to me. Just think about everything I've done here. n.swapNode.is none. Okay. Self.left equals none. Yeah. Otherwise, we don't update it because we do the internal mutation on the actual node. We actually update the values rather than truly swapping out the nodes. Yeah, I mean, I guess it does actually make some sense to call this like to say swap node. It kind of seems like you're moving them around. It might actually make more sense to call that delete. Like we have delete from, and then this is delete, which is what my other function was. And then like if we actually did a full delete, then we would have none, and we'd set self.left equals none, like if it had no children. And let me just think about this. Self.value equals swap in.value. I guess the thing I was thinking of doing, but that would... that would make it a little bit more complicated. I mean, is it more complicated or is it actually clear? Like if we just start with if we just start with taking self.left and instead here we return the node we want replaced. We'll worry about it later. Let's just try to get the right side working. Okay, so before we move on, let's go ahead and test this and make sure that we forgot I restarted. CD OSS Rust DSA. Okay. Right. Yeah, I forgot that I did that. Okay. Let's see. Where do we have all of those delete calls? There. Okay. Not what I meant to do. Not what I meant to do. Emacs commands instead of vim commands. Classic. Okay. There's that. Now let's try this. Node.delete value. And where's that at? 177? Oh, right. I didn't update this either. Oh, value used here after partial move. Okay, that makes sense. That can be a reference. 85. I think it can be a reference. Let me think. I mean, if let sum swap in self.value equals swap in dot value. Yeah. I mean, ideally, I'm... Let's just try seeing what we can get. So I know that's going to end up being a T. It doesn't implement copy, so I can't just copy it. Can I do like a deref there? No? Okay. Let me think about this. So I have immutable reference to self. I own that swap node currently. And in some ways I don't care about... Yeah, I mean, I don't actually care about replacing it in a way. Let me just think about this. As in, I don't care about owning it. I don't really care about that value. I mean, it does feel right if you say swap node on self that it's going to return the node that you just swapped it with. That feels reasonable. Yeah, okay. If let sum swap node, then ... Okay, yeah, that's not terrible syntax. It's a little bit more verbose, but it's fine. Okay, So we'll just do this. And we'll say turn some swap in. Else none. Oh, does this still... You're still saying that I'm partially moving it, of course. Okay. I mean, you're not wrong. Dang it. I thought that would have fixed it. Alright, let's see. Okay. Value partially moved at swap in.value. Yeah, I mean, the thing is, I don't actually care about that node anymore, which is what I keep coming back to. I own it, but it makes sense that I can't just return it as it is. I guess the other thing that's actually not completely correct about this is the swap node as it is isn't correct in that it's not updated with all of the children. So once I've updated self.value to swap in.value, maybe what makes more sense, yeah, I could see this. Okay, what makes more sense, we'll just leave all of that there, and it makes more sense to actually return self. And this is fine. It should just say that it's not the right type, and we just will get rid of the box. And instead return an option of self. Okay, but you still don't like it. What don't you like? Oh, it's a option. Yeah, okay. It's just not the right type. Because here, I mean, let me think about this. Somebody still has... Yeah, okay, that's fine. That's fine. We can just do this. It's reasonable. Just returns that mutable reference back in an optional. Sure. Why not? Yeah, this is fine. Yeah, okay. I think we're good. I think we're good with that. Let's see if we have any other issues. Nope. Okay, so test passed. We just have to make sure that our structure is correct. On first glance, it looks right. I have, oh, what was supposed to be my source of truth. Oh my god. Oh yeah, no, I forgot. I implemented this amazing auto scene switcher. And by implemented, I mean I turned it on. Yeah, this is good. Me forgetting to switch scenes is going to happen a lot less. Pretty excited about it. Okay. Very cool. Yeah, so let's just get this set up so that we actually do what we want to. Make sure it's doing what we want it to do. I'm just creating a new Emacs frame so I can easily see it as we're going along here. Okay, so we have a 10. We have a 7. We have a 15. We have a 9. We have a 4. We have a 17. And 3458. And 2000. Okay, that looks good. And then what do? We insert a 1, 5, and 6. 1, 5, and 6. Okay, and then this doesn't make a heck of a lot of sense with the way that, like at the end, but it was just as we were exploring through this. We delete a 7. We insert a 4, and then we delete a 6. Okay, let's see if that is what we want. So we have a 10, and then on the left we have a 5 that has a left of a 4, a left of a 1, and a right of a 4. That is correct. And the 5 has a right of a 9. The right side shouldn't have changed at all, which is 15, 17, 34, 58, and 2000. Yeah, that looks good. Okay, sweet. So that means that left side deletion after refactoring is working, and we can apply the simple logic to, much more simplified anyway, to the right side. Let's just do this. Okay, looks good. And let's see. We want to delete 22. Oh, of course, that actually had what I wanted at the end of it, but that's okay. We'll say some value there. And then we're just going to say if n.swapNode that is none, self.right equals none, and return the value. Okay, this looks fine. So let's think about the right side. Modprog, what's up? How's it going? How was your stream? Little shout out for you if you're, yeah, I hear you, no worries. Have a good one. I appreciate the raid. Welcome raiders. How did it go? More proc macro work? Sweet. Yeah, welcome. I know you guys were watching Rust, and now you're watching Rust still. We are working on a binary search tree. I'm using this little visualization tool just to help me during tests and make sure that I did the right thing. So I believe we finished delete. I just finished applying the right branch logic that we started with on the left. So this is where we're at. It's not the prettiest code I've ever written, not even the prettiest Rust I've ever written, for sure. But it's there, and it's maybe working. We're about to test out the right, deleting something on the right side. So yeah, that's what's up. We've been working through a bunch of data structures. I guess I should show you guys real quick what we've done so far. So we started with an array list, and an array list just had a vec underneath, which is an array list in case you don't know. And yeah, we just worked that out. Paripi Toke, thank you for the follow. I appreciate it. Welcome. So that was that. And then after the array list, Hakumer Matata. That's pretty good. I like that. Welcome. Yeah, thanks for the follow. And hello. You said hello earlier and I missed that. ADHD, you know, sometimes I miss things. So we started with an array list, and then we did a stack using unsafe, and that was fun too. And just really simple stack, just pop and push for the most part. But you know, it was my first unsafe Rust. It was cool. And then after our stack, we went into linked list, singly linked list, where we used a bunch of boxes, a doubly linked list where we used RC ref cell, and then we did a ring buffer, which was again using unsafe, and that was a lot of fun. Probably one of my favorites we've done so far. And then now we're getting into our binary search tree. It's taken me a while to remember how the algorithm works for delete, and then to actually code it properly, just because of the way I'm trying to do it. Partly what that is, let's see, we don't need that buffer anymore. Partly the way I'm trying to do it, which has made it less ergonomic than it could have been, is just checking on my dog. I've been trying to do it all in impl blocks without having any functions outside of them. And the reason that that's a little less ergonomic is because basically, like, the way that you're doing delete and a lot of traversal, a lot of tree operations, just like any other kind of recursive data structure, you're using a lot of recursion. Yeah, sweet. So yeah, if I just was recursing over what I actually have is like an option. Here, we'll go to my struct. If I was recursing over option box node t just in an outside function of the impl blocks, a function outside of the impl blocks, it would be a lot nicer code. But I wanted to see if I could do it all within impl blocks. So basically our recursion mostly happens in our node impl blocks, and then you know, we have kind of our public API, of course, in the actual binary search tree impl. So that's kind of where we are. So yeah, you're completely clueless here as a self-taught ready Andy Keck, huh? Andy Keck. I said that like it's a name instead of Keck meaning something, you know, like laughing, right? Good times. Yeah, totally cool. I've been developing for 10 years, or well, I've been developing longer than that. I've been paid to develop software for 10 years. I work in Clojure during the day. I have for the last 5 years. This is Emacs. It's partly why Clojure, Emacs, it just kind of goes together most of the time. Before that, I did TypeScript, JavaScript, and Java, full stack stuff. Mostly just do backend now. Been in Rust for probably the last 3 months or so. And I've found data structures to be a fun way to like learn more, you could say more advanced parts of the language, you know. So that's kind of where we're at. Still feel like a noob most of the time because because I still forget like really basic things, and my intuition for like the borrow checker and stuff isn't always correct. So there's that. But yeah, welcome again, and if you want more of this rusty data structure action, then feel free to follow, and you'll get more of it. So now I think we just need to test our delete on the right hand side, so let's go ahead and do that. First, let's decide what we want to delete, like in a reasonable order, so we can kind of make sure that different logic works. Yeah, absolutely. What are you getting paid to do your development? Paripi toke? I don't know an easy way to say your pari. Should I call you pari? Should I call you toke? Of course, I think toke, isn't that more like tokee or tokei? I could be wrong though. No, I remember looking it up one time. Because there's a Rust tool called toke. Did you know that? There's a Rust tool called toke. And here it is. It's a very cool tool. You can use it whether you use Rust or not. It counts lines of code and explains to you what you have in your repository or in the directory you run it from. So yeah, you just got a entry-level front-end job recently. Sweet, congrats, that's awesome. I mean, I started basically on the front end, so I get that. I quickly moved into full stack at my first job, and then found a lot more love for the back end myself, so that's where I focused on. So let's see. We have some options for deleting on the right. We want to make sure that, let's see, I think one interesting example that we didn't test on the other side, if I remember right, is deleting something when it only has the left branch. So I'd say let's start with deleting 3458. And then we should just have like only a right branch left, and we'll see if we want to do something else from there to actually get a good test. So let's just do this. I should say, if you are into the YouTubes, you can catch the beginning of this series on YouTube. There's the playlist for it. You can always just subscribe from that link, or if you want to go right to the channel, you can go there. And then I also just post random shit takes and stream announcements and stuff like that on the Twitter. So there's all those good links. And then if you just want to look at the code, it's on the GitHub and it's there. I think those are the main things you may want to know about. All right, so we wrote this. Let's just test it. The assert eq isn't doing very much for us. And it's not like I wrote a fancy test to make sure that the structure is what like I expected it to be. So we're mostly just doing print tests. we're printing things out and making sure that they're what we want them to be. Oh yeah, I forgot to actually print it. That might help. That might help a little bit. Okay. So let's jump here and let's get the last one. 195. Okay. So what we should expect to see is that the right-hand side, so we can skip the whole left, is going to be 15, 17, 2000, all on the right. Yeah, that looks good. You found memory management feels tricky, and learning DSA and at the same time can be difficult. Yeah, for sure. It is. I pretty much did it so far in this series, and it is not easy to learn all of that at the same time. Because, you know, for the most part, like, I mean, Clojure and Java are the main backend languages I've used, like, professionally, and both of those are JVM languages. You know, it has a garbage collector. It's very different, right? It's not low level. It's not a systems lang. Yeah, you can do some interesting low level things on the JVM, but like, it's very different than just using raw memory. Yes, Rust is my first systems lang. Yeah, so it's been, you know, like, professionally, I've picked up little things, of course, over the years that have to do with how memory works. And I don't have a CS degree, so, you know, how memory works and, you know, studying all those kinds of things. But as far as like actually having to think about and manage memory manually is not something I'd ever really done, besides little toy examples, you know. So this has been, I mean, is it still kind of a toy example? Yeah, a little bit, but you know, it's still been interesting to learn it this way. And a lot of data structures I already knew, kind of just from previous study. I did go through most of Prime's DSA course actually as well. That's what I originally started modeling this after. And so far we've only done data structures that he actually did in his course. We can do other ones, but so far that's what I've done, just because they're core, you know, core data structures that I think are good to know about and learn and kind of know how to implement. And definitely in Rust, it forces you to use all of the tools at your disposal to get it to work. So I've been pretty happy with how it's gone, but I definitely feel stupid a lot of the time. So that's part of it. Yeah, so let's see. So our right looks correct. We moved up to 2000 like we should have here. So let's go ahead and delete 3458 from here. I wish they had an undo button on this so that I could like easily go back to a previous state, but they don't. That's okay. Okay. And then let's see if there's anything else that I care about testing here. I guess I should just make sure that like 2000 was on the left, so we know that a single left child, single left node in, single child node in the left branch works correctly. Let me think. Yeah, I think let's just delete. Let's delete 15, and 15 should just be replaced with 17. So let's just delete 15, and then I think I'll be pretty satisfied that this is working. I said 15, didn't I? And okay. Ooh, I think we found a bug. Oh, weird. Okay. Unexpected. I expected my code to be perfect. Okay. So our root node is got 10, and on the left-hand side looks good. And then on the right-hand side, when we just deleted 15, 17 came up, but 2000 didn't. So somehow the right-hand side didn't actually work. And I think I actually know why that is. Let's see. How could we reproduce this on the left-hand side? Let's just see if we can fix the bug, and then we can see exactly where it is. Okay. So if we go into our delete from, we're on the right hand side. And we keep recursing down. We say value is less than n.value. Otherwise, we go down and get here. Okay, so eventually we got to this point where the value does equal the value, and that should have been at our 15. Let's see. I think we have some printing above that. Nope, I deleted that. Of course we did. Why would I want that? It's all right. We can rerun it. Yeah. So what do we do? So if 15 equals 15, we are going to say swap node is none, self.right equals none. Okay. And self.right is that one. Okay, that's fine. And then we return some value. So that means the logic breakdown is going to be in our swap node. So swap node is going to be called on our node that was 15, right? Or that is 15. And so let's see where that breaks down. Okay, swap node. So swap node starts by saying if there's something on the left branch, then look for the rightmost. Okay. And so there's nothing on the left branch of 15. So then we get on to our next, and that's going to say if self.right.isSum. So this would be if 15's right exists, which we know is 17, then we're going to replace right with left child. I see where the breakdown is. I think I didn't think about this. Yep, there it is. Yeah, that's the problem. So this is basically saying if there's no, so on the left branch, it's saying if there isn't anything on the right. Oh, I see what this works. Yeah, right. Replace left with left child, and it's fine if it's not. But replace right with left child is actually wrong because it could have a right child to replace it with. So let me just see here. I think this is the only place I use this replace right with left child. Let's just make sure. Replace right. Yep. Wait, no, swap. Is that the same place? And I'm just like being. Oh no, it's right there. It's on the recur right, which is a badly named function. This is true. Right, this is why I created this function to begin with. Is this whole replace right with left child. as we recurred right. And that was to deal with the situation actually where we had it before we deleted 3458, where it just had a left child of 2000, and then it was replacing the right node with the right node's left child. And that was pretty easy. And then I kind of just reused it thinking that it was going to have similar behavior, but it doesn't have the right handling. So I have to think about how I want to do this. I think this is the only place where I'm going to need this logic. I can probably actually make a replace right with left child just a little bit better. Maybe I should just call it replace right with child, and it will be replaced with either a left or a right. Yeah, I think that would work. We can also make it simpler. Right now I'm using an if syntax that is unnecessarily verbose, and we can make it more terse with an if let. Okay, let's try that. Okay, so let's just work on parity real quick with a nicer syntax, and then we'll see where we get. We'll just call it left child. Equals self.right.asMute dot unwrap dot left. Okay. And let's just put this up here behind a comment in case we need it again. Okay. Unwrap dot left. Okay, so let's think about this. Right, because in that L, like every single time when I call this, I end up taking it. So what we can do here is just do a take. And then we have that. Yeah, looks good. Okay. All right, so that compiles, which is nice. Let me just get rid of a couple of the debugs from the right-hand side. Oh no, this is when Emacs freezes. Error in process filter, args out of range. It's some sort of Rust tool set chain within Emacs that ends up like completely just killing Emacs. I'm gonna have to restart. You know, I've always assumed I have to restart. What if I just do a new frame? Ooh, does this work? Why didn't I think about this before? Oh my gosh. Sometimes I am silly. Okay, that looks good. And then we just have to bring it to the right place. And our OBS deal. And that looks close to right. Yeah, close enough. Oh, well, that's certainly faster than having to restart. Okay, give me a second. Just need to do a message check. All right, cool. Let's see how far we can get in 10 minutes. That's how much time I have left. All right, so we got that. Let's do that. And the rest are all on the other side. So that's good. Okay, so let's just test this. Make sure we don't have a regression on our left-hand side. And it looks good. 54149. Yep, that's what we expected. Very good. Okay, so now we're gonna see if we can refactor our replace right with left child function with a to just be replaced right with child. Okay, so we don't need that line anymore since we know it works. And let's see what we got. So if we have a left child, self.right.asMute.unwrap.left.take. Okay, so obviously if we're... There's a reason I did this. And it's because of the self.right.take. Okay, we'll just continue with terribleness and we'll make it better eventually. Else... No, come on. Else if let. Never actually done an else if let. Because at that point you should just probably write a match. Right? Let me think. Should I just write a match? I probably should, but I'm not going to. We're just gonna see if the syntax works. You usually like to put the right answer on the second parameter. Oh, okay. Good to know, Nathaniel. Yeah, I always make it consistent. So like I always put let's see. What do I usually do? Yeah. I almost always put the right answer on the left side. As in, like, I just make it consistent for projects and for tests. But yeah, interesting. Other people, that's your understanding of like a community convention? Do people just like the idea that right value is right? Could be. Okay. Okay, and then let's nope, it was the A that was wrong. Okay. Apparently correct syntax. It's kind of funny, and ugly, but it's okay. Let's just make sure that our left side doesn't have a regression. It shouldn't, because all we did is add a new else if. And we should still see 1054149. Yes, looks good. Okay, so now let's change this to with child. And we go down here. And we should be able to say that. And I think it's one other place, right? Yeah. Yeah, that looks good. Okay, so let's uncomment these. Yeah, the reason actually that I choose the left side, I mean, like the well, first of all, it's a net, and I would like push back on it. Obviously, if I was in a professional project with other people, I would, you know, follow the convention that the rest of the project followed. The reason that I usually like to put the right value on the left is because most likely, like especially in this sort of case, like my right value is terser than my right value. And so I just think it's easier to read. I know what I'm looking for. But that's just my own convention. I think I already ran this, but I don't remember because I got distracted. So I'll just run it again. Hey, look at that. We deleted 15 and we ended up with 2000. How about it? So I just want to make sure, let's see, I deleted 3458 when it just had a left child. I deleted 15 and that had a right child with a note underneath it. And I've deleted things plenty of times with left children. What if I just had left? Like left. I don't think that this will give me what I want. Because if I delete, let's see, if I delete 4, actually it will replace it with 1. What I want is a bunch of left children, but let's just delete 1. How about that? We'll delete 1. And then we'll delete 4. I don't know if I'm actually going to do this for my test. I just want it to... I mean, I could actually just fill in on the right side something that has a bunch of left children down, like on 2000. It's probably what I should do, actually. Now that I already screwed up the other side of the tree on here. That's funny. That's fine. So let's just do 1000. And then I'm trying to think of like, oh yeah, and then I just want 1,000 to have a, I just want 1,000 to have a child on the left side only. And make sure that when I delete 2,000, it's just going to switch it up and bring it up here. But let's just test one more case, and we'll go with 800 because we'll delete 1,000 and then we will delete 2,000 and make sure that works. Because from the parent's perspective, because the way we're looking at this function, from the parent's perspective, this is on the right hand side and we have slightly different handling. And then when we delete 1,000, it's on the left hand side. When we delete 2,000, it'll be on the right hand side. But both of the nodes we're actually deleting only have children to the left. So let's try that out real quick, see if it works. And whether it works or not, I got to go after that. So we'll see what happens. So let's see. We need to add some elements. So we're going to insert what? I already forgot. We're going to insert 1,900 and 800. Okay. 1,000. $900 and 800. Okay. And then we're going to delete 1,000. And then we're going to delete 2,000. And let's just do a debug print here. And we'll run it, and then we'll do the other debug print. Okay. Oh, failed. That's hilarious. Okay. That's fine. Did I already delete 2,000? Or did I never insert 2,000? No. Okay, very interesting. So it failed at the very last delete. So I did make a mistake. Okay, it's fine. We'll figure it out. So after I deleted 1,000, we ended up with 2,000 with a left value of 900 and a left value of 800. That actually looks correct. So I'm not sure what happened with the 2,000 in that case. 10, 5, 4, 1, 4, 9, 17, 2,000, 900, 800. So there's something that's getting fucked up when we try to delete 2,000, even though it's clearly in our tree. It's on the right hand side. Huh. Surprising. Okay. This isn't working for some reason, even though the tree looks right before this. Okay. Well, you know, it would have been nice to have a first try in there, but we didn't quite get there, and that's okay. Thanks so much for hanging out and for the raids and for the follows. And we're going to be back on Sunday. I don't stream on Saturdays in general, so we'll probably stream on Sunday. If you are watching and you don't already follow, you want to, then why aren't you following? That doesn't make sense, right? Even the way I frame that doesn't make sense. All right, good deal. Let's see who we can raid. Could raid Eduardo. He's doing a bunch of crazy language theory stuff. Let me just double check that there's not like a Rust Raider or something. And we get some waifu action right on the home page, so that's always fun. Live channels you think I'll like. Unlikely. Unlikely. All right. Just me streaming Rust. Anybody really exciting streaming besides that? I don't think so. I think we'll just raid Eduardo. I think that's good. Cool. Eduardo RFS. All right, awesome. Thanks again, guys. We'll see ya later.